3.1, ratios, rates, and equivalent ratios. A ratio is a comparison of two quantities that have the same units of measure. A rate is a comparison of two quantities with different units of measure. So an example of a ratio that you may have seen before is the Trident commercials where it says, dentists recommend it 4:1. When you look at these commercials, what they're saying here is that for every 4 dentists that recommend Trident, there is 1 dentist that does not. So out of a group of 5, 4 would be in support, 1 would be against. Ratios and rates can be written in several different ways. One is using a colon like this. Usually we'll see that in commercials or things where we want to see things really clearly. One is as a fraction, and later we'll talk about the difference between a fraction and a ratio, but we write it as a fraction in order to find equivalent ratios, and sometimes we write it using words. This is when we're kind of putting it in a report of some sort where we're trying to report it to other people. If it's a ratio, we usually use the word 2, so 4:1. If it's a rate, sometimes we'll use the words per or for, depending on the context. And later you'll see when we're talking about miles per hour or dollars for an ounce, you'll see that in a little bit. So here are 4 examples of ratios and rates, and we're going to try and kind of sort them in between the two. So if I have 16 bananas for $3, I'm comparing bananas, which is 1 unit, to dollars, which is a second. So that's going to be a rate because those 2 units are not the same thing. This is talking about girls and boys. 13 girls compared to 14 boys. Although girls and boys are clearly not the same thing, we're talking about 1 unit, which is people. So this is actually a ratio of 13 girls to 14 boys. This is another one that looks a little bit tricky because wins and losses are not the same thing, but because wins and losses are both talking about games, we're talking about 1 specific unit, and that's a ratio. Miles per hour is a rate because we're comparing miles, which is 1 unit, to hours, which is a second. So what's the difference between a fraction and a ratio that we write as a fraction? So let's say I have these smiley faces here, okay? And the example is how many of these smiley faces are smiling. I can express that answer in 2 different ways. One is as a fraction. A fraction is a part to whole comparison. So the part goes on the top, the whole goes on the bottom. In this case, there are 1, 2, 3 smiley faces that are smiling, so the part that are smiling is 3. My denominator is the whole amount, which is 4. That's my fraction. A ratio is usually a part-to-part comparison. So in this case, we would express this as 3 smiley faces that are smiling compared to 1 that is not. We can also express the same thing as a fraction of 3/1, but it doesn't mean the same thing. In this case, 1 is not my whole. 4 is my whole. This is a ratio of how many are smiling compared to how many are not. So here's an example of a type of problem you'll see where we need to use equivalent fractions, which will help us find equivalent ratios. So the ratio of teachers to students at DSST Cole is 2 to 36. So I'm going to start by writing that as a fraction, because I'm going to use equivalent fractions in order to find equivalent ratios. If there are 52 teachers at DSST Cole, how many students are there? So I know that I'm going to have something where it's an equivalent fraction, and 52 either needs to go here or here. I don't remember which one, so I'm going to start over here by figuring out what this 2 stood for. The 2 applies to the teachers because teachers was listed first, and 2 was listed first. So if this is teachers, that means down here is students. So I need to make sure that my teachers lines up on the numerator and my students lines up on the denominator. So I have 52 teachers at DSST Cole. That means 52 is going to go up here, and my unknown, or my x, my variable, goes on the denominator. So I'm going to use equivalent fractions here to solve this, and I'm going to find out what I need to multiply 2 by to get 52. And I know that's 26. So I'm going to do the same thing to the denominator because I know that's how I find equivalent fractions. I'll come back over here. 36 times 26 916. So that's going to be my value of x, That means that if there is a ratio of 2 teachers for every 36 students at DSST, that when there are 52 teachers here, there are 916 students. A second example we might see this in is if a town considers whether or not to put curbs on the side of the streets. The ratio of people who support putting in curbs to those who oppose it is 2 to 5. So first I just want to figure out what that 2 and 5 mean. So because this says the ratio of people who support to people who oppose is 2 to 5, that means that the support is the 2 and the oppose is the 5. It goes with whichever order you see it in originally and in the ratio. So the support is 2, the oppose is 5, which means total there are 7 people we're talking about. So when the first question asks me what fraction of the people oppose putting in curbs, I have 5 people who oppose it, that's the part, out of 7 people total who were asked. So my fraction of people that oppose putting in curbs is 5 to 7. If 210 people in town were surveyed, how many people support putting in curbs? So in this case, I need to use equivalent fractions and equivalent ratios. So I'm going to look at how many people support putting in curbs, because that's what it's asking me, over the total number of people, because that's what they're giving me. So I have the people who support up here is 2. The total is 7. That's my known ratio. My unknown ratio is that I don't know how many people support, but there are 210 people total. So in order to solve this, I'm going to use equivalent ratios again. And I'm going to say 7 times 30 is 210, which means 2 times 30 will give me my answer for my numerator, which leaves x equals 60. That means 60 people in this town out of 210 support putting curbs in on the side of the road. Last examples that we have this chart here, and this tells us what kind of movies 7th and 8th graders like. So it says here that 7th graders like action movies, 98th graders like action movies, and so on. It says that class at Kingswood Regional Middle School collected data on the kids' movies, on the kinds of movies students prefer. Complete each statement using the table. So now, letter A. What is the ratio of 7th graders who prefer comedies to 8th graders who prefer comedies? So I'm looking at just comedies right here, which means I'm looking at this row of my table. And I want to make a ratio of 7th graders to 8th graders. And I'm only looking at comedies. So the 7th graders who like comedies is 105. The 8th graders who prefer comedies is 150. And I could keep it like that. That is a correct answer. It's not the best answer because I can simplify this ratio just like I would simplify fractions. So I'm going to do that by dividing by 5 here. And I would get 21 over 30. And I know I can divide by 3 again here. And I get 7/10. 7 to 10 is the ratio of 7th to 8th graders who prefer comedies. And again, I use the word to there for this fraction bar instead of out of like we would with a fraction. What is the fraction of students who prefer action movies? So we're talking about total here. It doesn't say 7th or 8th, but we're looking at action movies. So I need to look at the total number of people who like action movies out of the total number of people altogether. And I'm going to put that as a ratio. So I'm going to add 90 and 75 and get 165. And I'm going to use a colon here just because I feel like it. And in the denominator here, I'm going to have the total, which is 180 plus 240. And that is 420. And I can simplify that just like I would simplify a fraction. So again, I'm going to write it over here like a fraction to simplify it. I know I can divide by 5. And I would get 35 on the numerator and 84 in the denominator. I probably can keep simplifying that. I'm not entirely sure. So right now I'm just going to keep that as my answer of 35 out of 84. So I wrote this as a ratio, and now I'm realizing that it actually says fraction. So instead of this, I need to write it as a part of the whole, which is 35 84ths, which means that this is not right. Last question, the GVR football team has a win-loss ratio of 3-1. That means that every 3 games that they win, they lose 1. If they have played 16 games total, how many have they won? So, I am looking at how many they have won out of the total games they've played. They have won 3 games, this is the ratio I know, out of 4 total. Now it's telling me there are 16 games total, and I want to know how many they have won. So I'm going to use equivalent fractions, times 4, times 4, and I'm left with x equals 12 games that they won out of the 16 games that they played.